All right. Well, we're going to get the class started. So what we'll do today, the first thing is to probably talk about the solution to the homework assignment. Um, so let's go ahead and start with that. So your homework assignment was recursion 1, and there's a new homework called recursion 2. So this is your new homework assignment. Once again, you have 1 week to work on it. So we'll go back and talk about recursion 1, which was due a few minutes ago. So we'll go take a look at this one, and we'll first take a look at the source code. So this is the source code of, or the program of the program that you're supposed to trace. And we'll do it the same usual way, which is to take a picture of this and then go ahead and trace it. Okay, so we'll take a snapshot here. Okay, um, that's exactly what I want. All right, so we put it right here. And I thought I had a spreadsheet already started for today, but I might have put it somewhere that I cannot remember. That's okay. We'll go ahead and find it. Here we go. All right, so first thing first is to kind of track this particular algorithm. So do we have any general question about tracing this particular algorithm? Any question I should address before the mechanical part of tracing it? No questions? Okay, all right. So I'm gonna trace it anyway, even though you guys do not seem to have any questions. All right, so we got comments because in this case we definitely have conditions to evaluate. And then we have the line number. The precondition, once again, we don't have any global variables, so there's nothing to say about in the precondition. We start execution on line 8. On line 9, we allocate for local variable x. So we allocate the leftmost available column, which is column C, for local variable x, which starts with an unknown value, with a question mark over here. And we can shrink this one a little bit. Then we move on to line 10. So line 10 is, this is the first time we get to line 10. So when we get to line 10, we realize that we have an assignment operation, but the right-hand side is a function call. So that means I can't know what the right-hand side value is right now at this point. So I have to call the function f. When function f returns, I can then figure out what is the right-hand side of the assignment, and then we can complete the entire assignment operation. So that means we have to call function f, and then we have to return back to line 10 to finish up what is left on line 10 that we need to do. So that means we need a return info, and the return info says we have to go back to line 10, and what is left to do on line 10 would look like this, with the question mark replacing the function call that we are trying to handle at this point. So that's column D. But because function f has two parameters, b and e, we also need one column for each. So column B and column E will be allocated one column each using the same method, which is the leftmost available column. So for this class, if you reverse the two columns, in other words, if you use column E for parameter E, and then you use column F for parameter B, that's okay. Okay, that is not a big deal for this class. All right, so because these two are not passed by reference, because we did not talk about pass by reference last week, that was a topic that we talked about on this Monday. So that means we are just simply using the value of this zero, which is the argument, to specify the value of parameter b. So zero goes here, and then e is going to start with the value of 3, like so. So now we are done with all setting up all the columns for calling function f, and then we continue execution in function f. Line 1 doesn't really do anything, so line 2 is the first line that start to do something useful. B has a value of 0, E has a value of 3, so B equals to E is false. And as a result, we go to the else branch, which is on line 5. So line 5 is ultimately a return statement, but we cannot know what it is supposed to return until we evaluate, the addition. But the addition, on the other hand, also relies on the left-hand side versus and also the right-hand side, and each one is a function call. So at this point, we really have no idea what it is going to return. So that means, we have to perform one function call at a time. And you can use the right hand side first or the left hand side first, but since most of us read from left to right, so we're going to start with the left hand side. But if you start with the right hand side, I'm not going to mark you wrong. So that means, this is the first time we get to line 5. When we get back to line 5, we have quite a few things to do. So the return info is going to indicate that we have to return to line 5, and the return statement is yet to perform. We're only handling the left-hand side of the addition, so only that side is replaced by a question mark. The right-hand side is going to be verbatim as what we see, in the code, because that is not being handled right now. So that part is just, copied from the original code. So we can use wrapping around, in this case, but we'll get to that point, when we get to that point, because right now, this is a little bit more clear. But every time we call function f, we also need to pass parameter b as well as parameter e. So in this case, b is specified by just my current b. So the current value of b is just 0, so we're going to pass the 0 here. And then e, on the other hand, is b plus e divided by 2. So b plus e is a 3, 3 divided by 2. In this case, we only keep the quotient, so that means it is just 1. Do we have any questions about how b and e are set up in column h and I in this case? Yep. On row 11, why don't I evaluate the second function call? So we can only do one function call at a time. So you have to pick. Either we deal with the left-hand side, which is the one that I have picked on doing, or you can start with the right-hand side. So you cannot do both at the same time. You can only do one function call at a time. So are we good so far? Okay, so did you start with the right-hand side and then go back to the left-hand side? Can you speak a little louder? Uh-huh. Okay, so I don't know exactly what you wrote in your submission, but if you start on the right-hand side, then we will have a different B and E, and then we'll have the left-hand side, remaining as verbatim in the return info. Okay, so either way, we can only do one at a time. Okay, so so that means, there's an alternative here. People who want to start with the right-hand side, they can do so, but it's not gonna change the number of rows of the trays, because you still have to come back and deal with the other side. Okay, so I'm gonna keep it the way it is right now because I think most people, go from left to right. So now we continue execution on line 1 again. And then we get to line 2. Once again, we evaluate whether B and E are the same. But this time, when we look at B, we are looking at the rightmost column that is labeled B, which has a value of 1. And we're also looking at the rightmost column that is labeled E, which has a value of 0. So 0 and 1 are not the same. So B equals to E is going to be false again. So once again, we go to line 5. So this is on line 5, and this is the first time we get to line 5 of this particular invocation of f. So that means, this is the first time we get here. So we're going to take care of the left-hand side again. So return info looks exactly the same as the other one. Because we still have a return to do, we're trying to handle the left-hand side of the addition, and then the right-hand side remains the way that it is specified in the code. So that part has no change. But then when we look at the B and the E, the B is still the same. B is still a 0. But E this time is going to be 0 plus 1, which is 1. 1 divided by 2 is a 0 because of the way division is defined in the homework assignment. So at this point, we continue execution on line 1 because it is a function call. The function being called starts on line 1. So we go to line 1 again. We get to line 2. And this time when we evaluate b equals to e, it is true. Because this time when we look at the b here, it is the rightmost column that is labeled b, which is column k, which has a value of 0. And then when we look at e, it is the rightmost column that is labeled e, which is also 0. So that's why, b equals to e is true this time. And as a result, we fall through to the then statement, which is column B, excuse me, line 3. Line 3 is returning 1 minus b mod 2. Okay, so that means that we have to look up the rightmost return info column or info cell, copy and paste it, and then change the question mark to the value that we are actually returning. So can someone tell me what is 1 minus 0 mod 2? In other words, I'm asking what is 1 minus the remainder of 0 divided by 2? What would that be? Nope. Oh, okay. Yes, the whole expression is 1. Okay, that is correct. The whole expression is 1. That is true. Okay, so we are putting a 1 here. Okay, so we put a 1 at this spot. And then it's done. We skip one row, and then what we do is we copy and paste the return info cell that we just modified so that we can remind ourselves where we're going back to and what else we have to do on that line. So now column B needs to be a little bit wider so that we can see the entire thing. And then at that point, these 3 columns are no longer in use because we are done with that particular invocation of function f. So they're all deallocated at the same time. And now execution goes back to line 5. And this is what is left on line 5 that we have to do. So now we go like, okay, we have to call function f again because the right-hand side of the addition is another function call, and I need to know the return value of the function call on the left-hand side, right-hand side, sorry, on the right-hand side to actually come up with the expression or the value that we need to return for the return statement. So now we have to call function f again. But at this point, when we need to call function f, column J is available again because we just deallocated it. So we are going to reallocate it for return info. And then this time, we have to remind ourselves that after function call is done, we have to go back to line 5. But this time, when we get back to line 5, we only have this much to do because the one on the left-hand side of the addition was already resolved. So we are only resolving what is on the right-hand side of the addition, and that's what the question mark is indicating, and that is really just the function call itself, that is being handled at this point. But we still need to reallocate column B and column E. Excuse me, we need to reallocate column K for B and then column L for E. And then those two respectively will be, okay, these should go here. So in this case, we are passing B plus E plus 1, the whole thing divided by 2 for B. So we have to look at this B and E over here. So B is a 0, E is a 1, and then we have to add one extra one, so that becomes 2. 2 divided by 2 is 1. So we put a 1 over here. And then E is just being passed as E itself. So that's why E is just, 1 also, because this E, I should say, this E here is referring to the E that is already in existence. So that's, that has a value of 1. Are we okay with this part? Okay. So once the columns are all set up, we go back to function f, starting at the beginning. On line 1, doesn't do a single thing. Line 2, b equals e is true again, because this time your b and e are in fact the same. Okay, they're both 1s. So we basically go to line 3 as a result, which is our then statement. So this time we have to look at b, and we have to evaluate 1 minus the whole thing, which is b mod 2. So what is the remainder of 1 divided by 2? That's 1, and the 1 minus 1 is a 0, so we're returning a value of 0. That is correct. So as a result, we copy and paste the rightmost return info cell, change the question mark to the value that we are returning, which is 0. And then we copy and paste this over to one cell or one row below this. So this is copied over here to remind us what we need to do on line 5. And then after that, we deallocate these 3 columns again because we are done with another invocation of function f. So now we return back to line 5, and it looks like something that we can handle now, right? Because what is 1 plus 0? That's just 1. So we're returning a value of 1 this time. The execution of a return statement means we have to look up the rightmost return info cell, copy and paste it, change the question mark, in this case to 1, and then skip one row, copy that to column B, and then deallocate the columns. Okay, so all of those steps are exactly the same as before. So now we look up the rightmost column that is labeled return info. It's not column J anymore. Column J is just deallocated. So when we look it up, it will be column G this time. So we copy and paste column G and then stash it over here. And then we change the question mark to the value that we are returning, which is 1. And then we skip one row and then copy and paste the return info cell over here to remind us by the time we get back to line 5, this is what we need to do. And then once again, we have no use of columns G, H, and I this time. So we copy and paste this and basically deallocate columns G, H, and I. And now we are once again getting back to line 5, except the right hand side of the addition is yet to be done. So, do you guys want me to finish the whole thing, or you guys already kind of get a gist of it? So we're good? You want to finish it? Okay, sure, we can finish it. So, but I'm not gonna explain as much, because most of these are really kind of the same thing. All right, so we are handling the function call on the right-hand side of the addition. So we have to reallocate return info this time. And then, the return info is going to say return 1 plus, and then the question mark, because the question mark is replacing the function call that we are handling at this point. We also have to reallocate column H and I for parameter B and E again. But this time B is going to be based on B plus E plus 1. And this is the B and the E that we are talking about. So B plus E plus 1 is going to be a 4. 4 divided by 2 is a 2. So there's a 2 over here. And then E, on the other hand, is really just E, which is actually column F, which is a 3. So this is the next function call. And then once we set up the columns, we start execution on line 1 again. And doesn't do a single thing. We get to line 2. B equals E is false this time. And then we get to the else statement, which is on line 5. Line 5 is a return statement, but once again, this is the first time we get to line 5 for this invocation of function f. So the really important part is the concept of invocation versus the source code itself. Okay, so there are multiple invocations of the very same function definition, which is what we see on the right hand side. All right, so now we have to reset the whole thing. Once again, we have to allocate return info. But these 3 columns are currently in use. So the leftmost available column is column J again. So we reallocate it as return info. And because this is the first time we get to line 5, we basically have to copy the entire line, except for the function call that we're handling, which is the left-hand side. And then the right-hand side is really just the same as before, like so. And then we also have to set up one column for parameter B and one column for parameter E. So this time, parameter B is going to be just B itself, which is column H, which it has a value of 2. And then column E is going to be B plus E, the whole thing divided by 2, but we only use the quotient of the division. So 2 plus 3 is a 5. 5 divided by 2 has 2 as a quotient. So B and E are the same again. And then once we get that done, we can go to the function starting on line 1, go to line 2, and then line 2 ask, B equals to E, it is true this time because they're both 2's. and then we get to line 3. Line 3 wants to do a return, and it is returning b minus 1 minus, sorry, 1 minus b mod 2. B this time is a 2. What is 2 mod 2? 0. So 1 minus 0 is a 1. So we are returning a value of 1. That is correct. So now we copy and paste the rightmost return info cell, change the question mark from a question mark to the value that we are actually returning, which is 1. And then we copy and paste it to one row after the current one in column B, and then we deallocate again. So we now deallocate. I'm just being lazy, copy and pasting the struck out version. There we go. So now we're back to line 5. So we get back to line 5 a lot of times, okay? As you might have noticed, the key is what is the context of executing that line 5. In other words, which ones are my B and which column is my B and which column is my E. That changes all the time. Okay, so that is the part that you need to pay attention to. So right now we're back to line 5. We have to call function f again. But at this point in time, the column corresponding to B is going to be column H, which has a value of 2. The column that corresponds to E is going to be column I, which has a value of 3. So that is the most important part, is tracking which column provides the value for the references of these parameters. All right, so we're going to do it again, okay, because this is another function call. We're going to reset up column J, K, and L because we have another function call, right? So we have return info, and this time we are going back to line 5. But this time, the left-hand side of the addition is already set up. It is 1. The right-hand side is the one that we are dealing with. So that's the one that is replaced by a single question mark. And then we also have to set up a column for B and E, 2 columns, one for each. And then this B here is referring to the evaluation of B plus E plus 1. But this particular B is referring to a column that is labeled B that already has a value. That would be column H, which is a 2. This E is referring to column I, which has a value of 3. 2 plus 3 plus 1 is a 6. 6 divided by 2 is a 3, and that's why we put a 3 here. And then E is just E itself, which is referring to column I, which has a value of 3. So now we are set up with everything, all the columns, and now we can proceed to line 1 again, because every time you call a function, even if it's recursive, it doesn't change anything. You start from the beginning of a function when you call a function. So we start with line 1, we get to line 2, b equals e is true again, and then we get to line 3, and this time, what are we returning? B is referring to the rightmost column that is labeled B, which is column K. It has a value of 3. So 3 mod 2 is, so what is the remainder of 3 divided by 2? 1, that is correct. 1 minus 1 is a 0, so we are returning a value of 0. So that's what we do. We're going to copy and paste the rightmost column that is labeled return info, and then replace the question mark with the value that we're returning, which is 0, and that's all we do here. And we skip one row, okay, and copy that to column B to remind us where we need to go back to and what else we need to do on that line. And now these 3 columns, J, K, and L, are no longer in use. We can now deallocate those, and then execution continues on line 5 again. Well, on line 5, I think we can do it now, right? We can evaluate 1 plus 0 is really just 1, so we are returning a value of 1 this time. So when we execute a return statement, we look up the rightmost column that is labeled return info, which is column G. So column G is copied and pasted here, and then we change the question mark to the value that we are returning, which is a 1. Okay? So this is the most confusing part of the whole thing is, well, okay, there are quite a few instances like this, right? Because the cell that we are modifying looks the same as the statement that we're executing. So in your mind, you have to keep track of column B is what you're executing. It's telling you what to do, and then the effect would be on the other columns, or the return info columns. So that really is the most important part of this particular exercise. I just want to make it so that you have to do it many, many times. All right, so now we do the same thing, skip one row, copy and paste, the cell that we just modified over here, and then we deallocate the three columns that are no longer useful at this point because we're done with another invocation of function f. So now we are back to line 5 again. So this time we know how to return because 1 plus 1 is just 2. So now we can execute the return statement with a value of 2. So what do we do? Same boring stuff. Look up the rightmost return info cell, which is this one over here. Copy and paste it, and then change the question mark to the value that we are returning, which in this case is a 2. Okay, skip one row, copy that, copy the cell that we just modified over here, and then indicate the three columns, which are the columns corresponding to return info. B and E are now deallocated. So we are now back to line 10. And when we look at line 10, we go like, yeah, we can do this assignment now because we know what is the right-hand side. It's just a value of 2. We know where it's supposed to store to, which is, whatever column is labeled X. That column should be column C. So column C is the one that is labeled X. So now we go to column C, and change that to a value of 2. And then we move on to the next line, which is line 11. It's return 0 in main, which means we are all done. And that gets us to post. Whew. Okay. So you can see that it really is a whole lot of repetition. If not for anything else, it is just a bunch of repetition. Are we good so far? All right. So this document is now available to you. So once again, my recommendation is to make a copy for your own. Okay. Then you can go ahead and highlight stuff. I personally would look at something like this as a whole block because this is representing the context that is provided to a specific invocation of function f. Okay, so that's why it is significant as a block on its own. So you can identify many of these blocks. So basically, if you see a struck out version of the labeling of the columns, you locate the closest one that is not struck out. That becomes a block of that signifies another invocation. But you can also see the invocations can quote unquote stack up because this invocation here, has okay. Let me just go ahead and color that because it's easier to see the coloring. All right, so what is the tool for coloring? There we go. Okay, so I'm gonna color that with a very pale yellow color. Okay, so with this pale yellow color, we can see that another invocation is stacked up right here, and I'm with a slightly different color, maybe it's just a very light blue-ish kind of color like that. And then I'll label this one with a very light greenish color, like so. There we go. All right, so this is really kind of important. This part is super important um, because what we see here is how the invocations are kind of stacking up. The yellow portion is one invocation, and then that particular invocation of F is nesting two additional invocations of F. The blue portion is one, the green portion is the other one. Okay, so I think this is probably the only time that you get to visualize how things are set up, the context in which a function executes, because you will encounter these concepts again. This is not a tag thing, okay? I guarantee you, this is not a tag thing. By the time you get to CISP 400, 430, and most likely 440 as well, the concept of a recursion will become increasingly important in those other classes. Okay, but you won't get a chance to visualize the recursive function call in this way anymore. This is a tag thing. This one is a tag thing. Okay, using a spreadsheet to help you visualize what happens in the recursive call, that is a tag thing. But the concept of recursion is not a tech thing. Okay, it is something that is going to be really important, for all the future classes that you will take in computer science. All right. Any? Yes. Go ahead. Question. Mm, but that's exactly what we're doing. We are calling f inside function f, like a parameter. Oh, okay, I see what you mean. So you're basically saying, what if a an argument of a function call, okay, what if the argument of a function call is by itself a function call? Yeah, that can happen too. Um, but in a recursive way, I cannot think of a way that's gonna happen. But it can happen with, at least with a different function, that can easily happen. But you do the same thing. Okay, so let me see if I can address your question with a sample program. Okay. So we'll address that question with a very simple question, okay? But before we go on to that one, are we okay with this particular answer? We all good? Okay, all right. So we are going to move on to a sample program to illustrate the point that we want to evaluate, or I want to address. We are going to. I'm just trying to check to see if my mouse pad is around. It's not, because I restarted the program. That's okay. Um, we are going to take a look at, I'll just call this test.cpp, and we are going to take a look at, this is my favorite is this one, Johnny as a function name. All it does is return 5. And then this is Ryan, and all it's going to do is return a 7, semicolon. And this is sum. It takes two parameters. It takes x and it takes y, and all it wants to return is x plus y. Okay. So in main, we use a local variable. We just call it x, or result. Doesn't really matter. Okay. So result is the sum of calling Johnny and calling Ryan. Is that kind of what you're asking? So in this case, Johnny does not need any parameter, but we do have, Johnny being an argument of sum, and Ryan, the function call of Ryan is also an argument of calling sum. So does it help address what you're asking? Okay, cool. All right, so we'll take a look at this one. So for the people who are asking why, Johnny has to do with 5, it has to do with, I think there are two movies in the franchise. It's called Short Circuit. So you can look it up. It's a really old sci-fi, with a cute robot. I think that was later on used to inspire Wally. Okay, so that's Johnny 5. And then Ryan and 7, because the character 7 of 9 in Star Trek Voyager is Jerry Ryan. Ryan is the last name of the actress. So that's how these names come along. Okay. All right. So now we are going to run this, to see how this is going to trace. And you guys will be surprised that this is not special in any way. We just do things exactly the same way that we always do. Okay. The important part is the ordering. Okay. It's like, okay, what do we need to figure out first? And then we can figure out what is next, and so on. Okay. So we'll go ahead and do this. And before we go any further, I need to shrink the font a little bit just so that it doesn't take up as much space when I take a screenshot of this. Okay, so I think that would be good size. So we're gonna take a screenshot here. I think I captured just enough of the line number, which is okay. That's fine. All right, so we'll go ahead, put it always on top, at the corner, and then we go back to the spreadsheet. There we go. All right, and I can stop maximizing, There's nothing really to say about comments because we have no conditions to evaluate in this case. So we got line number, we start on line 13, and we get to line 14. We allocate a column for result as a local variable of main, like so. And then we get to line 16 because line 15 is blank. Okay, we get to line 16. So the first time we get to line 16, we realize that I cannot really do the assignment, right? Because it depends on the function call of sum. Okay, so we go like, okay, we need return info in this case because we have to call. So now the question is, what are we calling? Okay, so I think that really is the whole important part of the answer to the question that you were asking is, okay, we have three functions. They all return values. So what is the first one that we should handle? So you got three choices, okay? Can we call sum at this point? The answer is no, we cannot call sum because sum needs the two arguments. One is parameter x and one is parameter y. Okay? Can we call Johnny? Does Johnny need anything else? It doesn't need anything else, right? So we can call Johnny. So that means we're going to call Johnny. Johnny would be the call of Johnny would be the only part that is replaced by a single question mark. Everything else stays exactly the same as what we see on line 16. So the way we track the return info in this case is the result equals to, can't do that yet. The call to sum cannot be done either. The call to Johnny can be replaced by a single question mark. That's one of the two function calls I can do. So the ordering of calling Ryan first or calling Johnny first doesn't really matter. But since most people read from left to right, I just do it from left to right too. The other call to Ryan is still not handled, so I'm just going to copy it to the return info cell. So that is how we set up the return info cell for this particular function call, is we can only handle the call to Johnny at this point. So that's the only one that is replaced by a single question mark. So other than this, everything else stay exactly the same. So now we go to line 1, which is the entry point of Johnny. We get to line 2, which executes the return 5 statement. So this particular statement just goes to the rightmost return info cell, copy and paste it, and change the question mark to the value that we are returning, which in this case is literally numerical 5. Then when this is all done, oops, that's not what I wanted to do. Uh, okay, undo, there we go. So this is what we usually do. Okay, we just copy and paste the cell that was just modified one row over in column B, and I'm gonna expand column B so it's easier to see. There we go. And now we don't have use of this return info cell anymore, so we just kind of strike it out, like so. And now we continue execution on line 16. So this time when we get to line 16, same kind of question. Can we do the assignment? Nope, because we haven't called sum yet. Can we call sum? Nope, not yet, because we don't know what the second argument is going to be. So this time we're going to call Ryan as a function. So it's the same kind of deal. We reallocate this column for return info, but except this time when we write down what else we need to do, we have one fewer or less thing to do. So this time the 5 is already determined from before. The question mark is going to replace just the function call for Ryan. And this is how we set up the second function call. After this, we go to line 5, which is the entry point of Ryan. We get to line 6, which executes the return statement of 7 as a value. So we go back here, okay, we copy and paste it. We change the question mark to the value that is being returned, which is 7. And then we continue execution, okay, but before that, we have to make a note on column B. In column B is to remind us, by the time we get to by the time we get back to line 16, what else is we're supposed to do. So at this point, we have no use of column D anymore because that invocation of Ryan is done. And now we continue execution on line 16. But so this time we get back to line 16, we ask the same kind of questions. Can we do the assignment? Because that's ultimately what we want to do on line 16. The answer is no. But can we call sum this time? The answer is yes, because we have already figured out the two arguments. in order to call sum, one is 5 and one is 7. So now we can finally call sum. But since we have to return back to line 16 again, so we need return info again. So this time when we get back to line 16, all that is left is result equal to question mark, because this time we're handling the sum, the call to sum. But in order to call sum, we also need two parameters. One is called x, one is called y. So in this case, it's pretty clear which one goes where. 5 goes to x, which is our first argument going to the first parameter, and the 7 as our second argument goes to the second parameter, which is y. So now we set up those two columns, and then we proceed to execute at the entry point of sum, and that would be line 9. Then we get to line 10. Line 10 is a return statement. It's still pretty simple. It just looks up what is x and what is y, calculate the sum, which is 12. So we're returning a value of 12. So once again, we look up the rightmost return info cell, copy and paste it, change the question mark to the value that we are returning, which is 12 this time. And then we do the usual thing. Okay, we just copy it to column B to remind us what else we need to do on line 16. And then this time we have three columns to deallocate, because this invocation is using three columns. And once the invocation itself is done, all three columns are deallocated, and then we continue our execution on line 16. Line 16 says, okay, the right-hand side is already evaluated. It is 12. What is on the left-hand side? Well, the variable that we need to change is result, which lives in column C. So that's why column C is now updated to a value of 12. We move on to line 17, and that's the end of the execution of the program. So does it help answer your question? Yep. Yep. So that part has to do with just ordering. It's just like, okay, you have multiple function calls on the same line, but you have to figure out which one has to be the first one. And you just handle the first one first. Now, if there are multiple ones that you have to handle like this one, then you just have to kind of deal with all of those in the same order. Yep. Yep. It's based on dependency. It's based on dependency. And you will find that, in computer science, a lot of times, the understanding of dependency is really important, because once you figure out what depends on what depends on what else, and so on and so forth, that really helps you to establish the ordering of how to evaluate things. I would say that's also a big difference between mathematics and computer science. Math, for the most part, has dependency based on definitions, but it's not based on the ordering of doing things. It's just, this definition depends on the other definition and so on. But in computer science, everything has to be sequential in the end. So as a result, we need to figure out what needs to be done first, what needs to be done second, and so on. And sometimes it's not just reading from left to right, like in this case. So, so I hope that kind of helped illustrate, the importance of analyzing the dependency of things. Are we good? All right, cool. All right, so with that done, we are continuing. I'm just making sure that I'm recording, because I think only half the class is here right now. um, I have no idea what the other half is doing right now. So anyway, we are going to talk about, binary search as an iterative function, and then we'll also take a look at yeah, and then we'll take a look at the recursive version of linear search. I think I'm going to change up the order a little bit. Instead, I will look at the recursive linear search function first, and then we might go back to look at the iterative version of recursive. Um, no, I take it back. The iterative version of binary search. All right. So let me take this one out, and then we'll substitute it with another program. Okay, there we go. So that would be leansearch.cpp. Um, yeah, this one looks particularly ugly. I think we can do it. Do you guys want me to do it like this, or do you want a slightly more readable version? This one is a nested, um, it's a nested ternary expression. There's a ternary expression within a ternary expression, which is actually just equivalent to a nested conditional statement for the most part. But if you want it to be easy to track, I can break it up into a just statements, conditional statements, which makes it a little bit easier to read. It's up to you guys. I mean, if you want to keep it this way, we can do it. If you want to break it up into a conditional statement where things are more line by line, we can do it that way too. So it's your choice. Hmm? So we want to break it down to line by line. Okay, we can do that. So keep in mind the line by line version is the same as this one. Okay, so I'm going to comment out the line so that it's still here. So for those of you who want to establish how the statement version is the same as the single expression version, you now have a reference. Okay, but for the purposes of tracking it, we're going to use the a little bit easier one to track. So we're going to use the same conditions, except this one is stated as conditional statements. All right. So if I is greater than or equal to n, we just return the value of false. Otherwise, we go for this one, which by itself is also a conditional statement. So this is the way I actually program when I'm on my own. Okay. I just put in the entire template of a conditional statement, and then I go back and backfill the condition, the then versus the else portion. The reason why I do this is I don't run into the problem of I have like 6 open braces and then trying to figure out which one this is supposed to close with the earlier braces. This way the braces are already here. I just have to kind of stuff the content between the braces. So I found this to be useful to me. Whether you guys find it useful or not is entirely up to you. This is more like just practices, right? What is the best practice for writing code. This one just going to return Leon search a and I plus 1 k, and that's it. There we go. So line 2, which is commented out, anything after slash slash is comments, which means the compiler does not interpret any of that. So line 2 alone by itself is equivalent to line 3 all the way up to line 11. Okay, so this kind of gives you an idea why ternary expression is kind of useful. It's kind of powerful. It's not as easy to read, okay, but a ternary expression can go any place as opposed to statements. Statements cannot be embedded inside something that expects a value, but an expression can go anywhere. Anyway, so we'll go ahead and track the program the way it is stated at this point. Okay, so do the same thing. We just take a snapshot of the code, and yeah, we can do it this way, but it's going to take up a lot of columns this time, but it'll be fine. Okay, let's just put it up here and then go back to the spreadsheet. And this is the one. So I'm going to open up a new sheet over here. And then we'll go ahead and take a look at how this code works. So we got comments, we got line number, and we start on line 14, which is the entry point of main. And then we immediately go to line 15. So line 15 was explained on Monday. Okay, it is a shorthand of allocating all the space that we need for a 6-element array called numbers, and also at the same time initializing all the elements of the array. So it really is just a shorthand. Okay, it is, otherwise I'll be using a lot more rows in the trace to do the same thing. Okay, so the way this works out is we just have to allocate enough columns for numbers. So to make it a little bit easier to read, I'm going to use the brackets to indicate which column is for which element of the array. And we can see how this is, well, I mean, once I shrink the columns, it will be a little bit easier to read. So with only 6 elements, we only go, the indexes, we go from 0 to 5, not to 6, because we start counting from 0. So now we shrink all of these. There we go. And I'm going to make it easier to understand that all of these columns belong to numbers as an array. So we're going to merge all of these particular cells together. So it become one. So format, nope, not insert format, merge cells. There we go. There we go. Okay. Now this particular thing also initializes those particular columns. So we're going to have 1, 5, 8, and then we got 20, 36, and 73 over here. And that's what line 5 is going to do. Line 15, sorry, line 15 is going to do this. Line 16 is allocating one more column for result, which is just a Boolean. So Boolean is only going to take up one column, but this one is unknown. It has an unknown value to begin with, like so. And then we get to line 17. So line 17 is an assignment statement, but until I'm done with the function call, I don't know what to use to change result. So that means we have to handle the function call first. So we need a return info to get back to line 17. When we do get back to line 17, what is left to do is pretty simple because the complexity comes from the function call itself. Line 17 otherwise is just an assignment statement. So it's the function call that is kind of mysterious. What is it going to do? All right, so since we are making a function call to lin search, so now we have to look at all the parameters. It has a bunch. Parameter A is an array being passed to it. So as we talked about on Monday, when we pass an array as an argument to a function in C++, all we are really passing is where to find the first column of the array. So in this case, which column would that be? This is a reference to column. What is the first column? Yep, column C. There we go. Okay, so parameter A is just a reference to column C. And then we have n. N is passed by value. So it really is just the 6 that we are using here. So n is 6. And then we have I being 0. Okay, so I is 0. Those are all passed by value as opposed to passed by reference. And then we also have k being 20, which is also passed by value as opposed to reference. On Monday, we talked about passing by reference as well as how to pass an array. So if you have not watched the video on Monday, that's important, okay? You really need to watch that video first. All right, so now that we are done with setting up all the columns, we can now continue our execution at the entry point of lin search, starting on line 1. Line 2 doesn't do a single thing. We skip it. We go to line 3. We ask the question, is I greater than or equal to n? It is false. We go to the else statement, which is starting on line 6. So on line 6, we ask another question because we have a nested conditional statement. So in this case, we ask what is a bracket I and does it equal to k? All right, so now we have to go back to the lecture on Monday because now we are going like, okay, what is a bracket I? So we look up A first. The rightmost column that is labeled A is column K. Column K says, don't look at me, look at column C, right? Yep. Hmm? Yeah. That's coming from here. Yeah. So K is, or I should say 20 is the fourth argument in the function call to lin search. K is the fourth parameter. So we match only by position in this case. Yep. All right. Okay, so getting back to line 9, we want to, nope, not line 9, line 6. We are on line 6 right now. So on line 6, we want to evaluate what is A bracket K. So we are treating A as if it is an array, so we try to look it up. Except the column that is labeled A, which is column K, says, oh, wait, I'm not an array. I just know where to find the first element of an array, right? So it says, okay, go to column C. Column C is the first column of the array that you want to access. So we start with column C, and then we ask, okay, but which column do we want? Um, it's A bracket I, right? And I has a value of 0, so we are really just looking up, element 0 of the array that starts at column C, which has a value of 1. Okay, so now we compare the 1 to k, and the value of k is 20. 1 equals to 20 is false. So we just answer that. It is false. And then we go to the else statement corresponding to the nested conditional statement, which is on line 9. Line 9 says, okay, let's go ahead and return lin search, except this time we're dealing with I plus 1 over here. Everything else stays put. So when we get here, we have to set up return info. Okay, return info is saying, okay, we need to go back to line 9 and execute the return statement. But the expression that we need to return, the entire expression is a call to lin search itself. So that means we only need one question mark over here to replace the actual function call of the return statement. Okay, so that's it for that portion. And then what else do we have to do? Well, every time you call lin search, you have to give it 4 parameters, right? So those columns are respectively A, N, I, K. Okay. So as it turns out, if you are passing a parameter that is already an array along to something else that is also expecting an array, all you're really passing along is this. Okay, so you just pass the reference to column C along, and that's all you need to do. So this is the most important part, okay, of today's lecture. In order to do your next homework assignment, this is actually the most important part. Is how do we pass a parameter that is an array to me to another function call that is expecting a parameter that is also an array. You just pass the reference along. That's all you do. Because when you use a parameter as an array, all it needs to do is to tell us where to find the first element of that array. Okay, so everything else stays about the same. Okay, n is the same. I is the only one that is changed. So when we execute line 9, this I is referring to the column that is labeled 9, that is labeled I, that is already defined, that has a value. Can someone tell me which column would that be? Column, yep, column M is the one. It has a value of 0, so I is incremented just by 1 to 1. K is the same, okay, K is maintained exactly the same as before. So that's what it looks like. And then we need to move this out of the way. So this is going to be a long, it's going to spread all the way to the right-hand side quite a bit, okay, because every time we recursively call lin search, it's going to set up, columns kind of like this. Then we get to line 1. Line 1 doesn't do a single thing. We get to line 3, and I can expose just enough portion here to see what it does, right? So on line 3, it says, what is I is greater than or equal to n? It is false again. Then we get to line 6. It asks what is a bracket I? Is it equal to k? It is once again false, because this time we're looking at element 1. And element 1 being the same as 20 is false because element 1 has a value of 5. So this is false. Then we get to the else statement, which is on line 9, which is going to do the whole thing again. Okay, so because it's going to do almost the entire thing again, I'm just going to do the lazy thing over here and copy and paste it, except for column I. Column I is the only one that is changed. Instead of 1, it is now 2. So it's going to be like this for a while. Okay, so I'm going to kind of not show this code for now. I'm going to hide this part just because we're going to have to do this quite a few times. Okay, all right, there we go. And now execution continues at the beginning of the function that we just called, which is line 1 again. And then we get to line 3. Line 3 is asking is k greater than or equal to n? The answer is no. We are actually quite a few steps away from that. So it is false. We get to line 6. It's asking does a bracket I equal to k? The answer is once again no. Okay. So that is also false. So at this point, I am going to do a little trick here. So the trick is you can use this bar, okay, drag this bar down so that you can expose, one portion of the spreadsheet and not change, not scroll that portion as you scroll the rest over here. And you can do another one, this vertical one, you can move it to the right-hand side so it's easier to kind of keep scrolling one portion without scrolling the other portion. All right, so we're still looking for the value of 20. Um, and I currently has a value of 2. A bracket I is the element 2 of the array that starts at column C. It has a value of 8. So we are not quite done yet. Okay, 8 equals to 20 is false. So we get to line 9 again. Line 9 is going to set up this whole thing again. Oof. Except this time your I is going to increment to 3. So let me go change the width of the columns, and then I is now 3 this time. Okay, so this is where things get changed a little bit because it's a little bit hard for me to see the columns lining up. There we go. We go to line 1, doesn't do a single thing. We get to line 3, I is greater than or equal to n is false, okay? Because I is 3 and n is a 6, so 3 is greater than or equal to 6 is false. But when we get to line 6, okay, this question is a little bit this time, okay? So we'll take a look at this one. So we look at column Y or column Z, sorry. We look at column Z as array A, and then column Z goes like, I'm not the array. I just know where to find the first column of the array that you need to access. It is back on in column C. Okay. So we go to column C and go like, okay, we know how to find element 0. Are we interested in column 0? No, the answer is we want are we interested in element 0, not column 0. Are we interested in element 0? No, we are interested in element I, which is element 3. So this is the first element. We go to element 3, which has a value of 20. K also has a value of 20 right now. So 20 equals 20 is, woohoo, it's true. Very good. So now finally we have true here. Then we move on to, I need to unhide the bitmap, which is here. So this time we get to line 7. Line 7 says, okay, let's just return true this time. So we go to line 7. It returns true, which means we look up the rightmost return info cell, which is this one here. We copy and paste it to here, change the question mark to the value that we are returning, which is true. And then we continue execution over here. Okay, but before we do that, we have to make a copy of the line that we need to execute in column B, skip a column, and then we also have to remember to, I can hide all of this now, by the way. So now we have to we have to deallocate all of these columns. Okay, so copy, paste, strike out every single one, and now execution point return that back to line 9. So line 9 says, I'm ready to return true. So that means we have to look up the rightmost return info cell. Okay, and that is column T this time. Copy and paste it. Okay, so from here, from this point on, it's actually not really difficult. The difficulty that I have here is because I don't have a um, larger screen with enough resolution. So now this part is kind of confusing. This is the statement that we're executing. This is the result of executing that statement. So that is the most important part, is which part is telling me what to do and which part is the result of doing that. Okay. So now we go like, okay, we are all done and we are going to make a copy of this cell. And then once again, we can now deallocate a bunch of columns like that. Copy and paste here. Oh, guess what? We're back to line 9 and we're returning true again. What do we do? Look up the rightmost column that is labeled return info, do the same thing again. This time it is column O. Okay, so we copy and paste that over here. Do exactly the same thing. We know that we are executing return true, which means we replace the question mark with the value that we are returning like that. And then we do the same thing. We skip one row in column B and remind ourselves what else we need to do when we get back to line 9 this time again. And then we have no use of column O to column S this time. So we just indicate that they are available again. We get back to line 9 again. We execute return true again, which is what we do is we look up the return info cell that is on, we look up the rightmost return info cell, which in this case should be column J. Okay, once again, just copy and paste it. And then you change the question mark to the value that we are returning, which is true, like so. And then we deallocate. Oh, wait, we do it over here first. Remind ourselves, what else we need to do after the invocation is done, and then after that, we deallocate a bunch of columns again. This time we are executing return equals true, which is, oh, I think we are ready for the assignment operation because the right hand side is just true as a value. The left hand side is result. So we look up the rightmost column that is labeled result, which is column I. So now we go to column I and go like, okay, you have a value now, which is true. And then we move on to line 18, which is return 0 in main. We're done. Are we doing okay so far? So I can imagine there are a few thoughts, okay, of people in this class. Some people might be thinking, we are doing exactly the same thing all over again, okay? It's almost exactly the same thing. This particular trace illustrates one thing that is important, which is illustrated earlier of what do you do when you are passing parameter A to the next recursive call, uh, to parameter A of the next recursive call. Let me go back and show you the source code so that we know exactly which line we are talking about. So I'm talking about line 9, okay? When you pass a parameter that is passed to you as an array, and you're passing it along also as an array, all you need to do is to copy the reference because all you need to do is to tell the next invocation which column is the first column of the array. So you just pass the reference along, okay? That is the only new thing about this trace. Everything else are essentially exactly the same as all of the other sample programs. Is that okay? All right. So we have about 13 minutes remaining. Okay, so we can go ahead and take a look at the iterative version of binary search as a function. But before we go there, I want to make sure that make sure that we address all the questions about this particular sample code because this one is more important than the next one. So I want to make sure that we don't have any additional questions about this trace. Yes, sure. So that would be way down here. So this is the first time. So the first time it returned a true is the first time we get to line 7. So if you look up your column B, you just go like, oh, okay, this is the first time we get to your line 7. So this is the first time we return true. Do you want me to hide this one so we can see more of the spreadsheet? Okay. So we are on line 7 at this point. We execute return true. So whenever we execute return true, we go to the rightmost return info cell, which turns out to be this one here, and we copy and paste it and change the question mark to the value that we are returning, which is true. So that's why when we execute line 7, the result is this. Um, so this does not do a single thing right now. It just resolved something that we needed from earlier, but we are not doing anything about line 9 right now. Okay, so what we do is we copy this line over to column B because column B is the one that tells us what line do we need to execute and what else is on that line. Okay, so when we execute line 7 on row 28, all we did was to resolve the next time when we get back to line 9, we know what we're supposed to return. But we are not at line 9 when we are at line 7. Is that okay? But in order to help us remember that by the time we get to line 9, we know what to do. That's why we copy the cell of Y28 to the cell of B30. That's why we make a copy of that cell. So then the next row is really doesn't serve any function other than indicating that column Y to column AC are no longer in use, and that's why we just have a bunch of stuff here that is struck out, right? So when we get back to line 9, which is row 30 of the trace, this is what we need to execute. Because by the time we get back to line 9 this time, we know exactly what we need to return. We know the value that we need to return. So we execute the statement in the cell of B30, but as a result of that, we do the same thing that we always do when we return a particular value, which is looking up the rightmost return info cell, which in this case would be T something from earlier. We copy and paste it. We change the question mark to the value that we are returning, which is true, and that's it. That's all you do when you execute a return statement. Okay. But then we also have to copy and paste T30 to B32 to remind us, okay, when we get back to line 9, what else do we need to do? They turn out to be the same thing over and over again because the point of the recursion is the same. Yep. So is that okay? Okay. Okay. So with a ternary expression, you basically go back to the same line over and over again. So let's go back to the source code because if you're asking about a ternary expression, so if you look at the ternary expression, there's only one point of recursion. So that means, it makes it harder to track because, it's hard to remember, which part of the ternary expression you're trying to evaluate. But you can always reevaluate the entire ternary expression in this case because we are not changing the value of I, we're not changing the value of n for each invocation, and we're not changing the value of k. So that means whenever you go back to line 2, if we were to use the ternary expression, you would still be able to reevaluate the entire thing and figure out, what you need to do next. In the case of a function call that has what we call a side effect, which means it can potentially change the value of the parameters, then we have a problem because you get back to the same line, but things have changed. So you cannot, so it becomes harder to track. But in this case, it's not a problem. All right. So let me show you. I don't think we have enough time to track the iterative version of binary search, which is not needed. Okay, that is actually not needed. Um, so instead of doing that, I can now show you the algorithm that you need to follow. So let me close this one, and then we go to the homework assignment for next week. Righty. So that's a bin search. I mean, it's not that one. It's recursive 2, recursion 2. So in recursion 2, I give you the algorithm already in this particular spreadsheet. And for people who are interested in actually seeing it in action, you can actually copy and paste this into online GDB or whatever C++ environment you want to use. And I have no idea why it is getting stuck. There we go. Okay. So you can see this one is almost the same if you look at what we call the prototype. It's really similar to the lin search. The only difference between this and lin search is it doesn't have an n, it doesn't have an I. Instead, it has b and e instead. Okay, but other than that, it looks almost the same. Okay, I call the array v instead of a. Okay, that's minor change. But you can actually plug this in once you substitute whatever is supposed to be in the braces and however you want to initialize k, which is actually in the assignment itself. So once these two have specific values, this program actually runs in online GDB. But what online GDB does not tell you is how the function call is supposed to happen, how to set up the columns, what are the effects of executing the return statement. But this one also does not make use of the ternary expression, right? Because we can see that there's a conditional statement here, there's a return here, there's an else if here, which is really just a nested conditional statement, another return here, and another return here. So this one, is not tricky to follow as in a ternary expression. It is about the same in terms of complexity as what we just did, except this one does not go for as many iterations because your entire array only has 5 elements. So it will only go for at the most 3 iterations before it come to a conclusion. All right. So in terms of the length of the trace, as much as this algorithm looks kind of complicated and long, I think the trace is going to be shorter than the homework assignment that was due today. All right. So we have 5 more minutes. Do we have any questions? Okay, so I'm just going to re-emphasize that I do have office hour from 8 to 9, right before this class. I don't have time right after the class because I have another class starting right after this one. Um, but after 1:30, I also have time. So for people who want to kind of talk to me about the topics that we are talking about, study skills and stuff like that, you can definitely come visit me because this is when the class gets a little bit more difficult. Okay, so I do have to warn people that it is going to be a little bit on the difficult side at this point. Okay. I have the same office hour 5 days a week. So from Monday to Friday, it is from 8 to 9 a.m. Yep. Okay. So I'm gonna stop the recorder for now, right now, and then